All right, so this is a lesson to review prior skills that you've learned in the past, reviewing angles inside triangles, and also the Pythagorean Theorem for right triangles. So these are skills you're going to need in this coming unit. So let's start with interior angles of a triangle. So there's a rule that says that no matter what triangle you have, if you add up all of the interior angles, so we see that here done in this diagram with the blue, the green, and the orange angles, A, B, and C, they will always add to 180 degrees. So if you have two angles inside a triangle, then you can always find the third one using this rule. So if I know they all have to add up to 180 degrees and I want to find this missing one here, I just subtract the angles that I already have. So I have 36 degrees for R and 51 degrees for P, and I subtract those from 180. Minus 36, minus 51, and I get 93. So that means angle Q has to be 93 degrees. Okay, so same thing here in this right triangle. Now, just a quick note, if you see a square in a right triangle, that means that that angle is measured to be exactly 90 degrees. So in this one, we'd have 180 minus 90, which gives 90, minus 46, which is 44. That means angle B here, the missing angle, is 44 degrees. Okay, so the other skill we want to review before we start this unit is the Pythagorean Theorem. So this is only true for right triangles that have a 90-degree angle. So this triangle shown here does have a 90-degree angle. So when you have a right triangle, there's a rule that if you take the squares of both the smaller sides, typically we call those sides A and B, then if you add up those squares, so the areas of these two blue squares that I'm shading in here, then they always add up to the area of the square along the longest side. And typically we call that C. So a lot of people remember this rule as A squared plus B squared equals C squared. A and B, those sides, they're often called the legs of the triangle. And side C, the longest side, is often, or is called the hypotenuse. Okay. So we can use that if we have two sides on a triangle. We can use the Pythagorean theorem to find one of the missing sides, and we can also use the Pythagorean theorem to see if a triangle does have a right angle. Like in this triangle here, it looks like this angle is 90 degrees, but let's make sure, let's check and see if it's exactly 90 degrees, or maybe it's just close. So this side would be side A, this would be side B. I can tell that because these sides are shorter. And then the longest side here, which we think might be the hypotenuse, we're going to call that C. So if this triangle follows the rule that A squared plus B squared equals C squared, then we know it's a right triangle. So let's plug in those lengths and see if this is actually true. So we have 7 squared plus 9 squared. That's equal to 49 plus 81, which is 130. And let's check what C squared is. 11 squared is 121. But I see that 130 does not equal 121. So A squared plus B squared does not equal C squared. So that means this is not a right triangle because it doesn't follow the Pythagorean theorem. You can pause the video here and try this for yourself on the next triangle. We want to take the two smaller sides. Those are both A and B. And then this is the side we think might be the hypotenuse here. So let's check. Let's do A squared plus B squared, the two blue sides. We're going to get 9 squared plus 12 squared. That's 81 plus 144, which is 225. And if I do C squared, that's 15 squared. That's also 225. Okay, so we do see that A squared plus B squared equals C squared. This is a right triangle. Let's see how we'd use the Pythagorean theorem to calculate a missing side length. Okay, so first thing you want to do when you're finding a missing side length from two sides is you want to identify which sides are the legs and which is the hypotenuse. So the side that's across from the right angle, see the right angle here? That side is always side C, the hypotenuse. That's always the longest side on a right triangle. So that means these two sides are sides A and B. So I'm going to set up my Pythagorean theorem like this. A squared plus B squared equals C squared. And I'm going to fill in the numbers that I do know. So I know we have 3 squared plus 14 squared equals C squared. 3 squared plus 14 squared is 205. But to find length C, that's what C squared is, I need to unsquare it. So I need to do the opposite of squaring, which is taking the square root. That's how we can calculate C. So let's type that into our calculator and see what we get. It's going to be a decimal number because 205 is not a perfect square. That evaluates, I'm trying to turn on my calculator here. There we go. Took a second. Okay, so I want to do the square root of 205. And I see I get approximately 14.3. It says in the question to round to the nearest tenth. That means one number after the decimal place. So C is approximately 14.3 centimeters. Okay, let's see how we would use the theorem to find one of the shorter sides. So this time the side that's longest is across from the right angle, the hypotenuse. I have that side, and I'm missing the shortest side here. So if you're missing one of the shorter sides, what you want to do is use your formula but in a different way to subtract instead, because if we have one of the longer sides, it's going to be C squared equals B squared. Oops, sorry. A squared equals, oh my gosh, I wrote that wrong. C squared minus B squared. So I'm going to plug in the numbers that I know, which is C and B. So I have 10 squared minus 8 squared, which is 100 minus 64, so 36. That's what A squared is equal to. And then to find out what A is, we just square root both sides. So this time it's exact. A is exactly 6, oops, I put the wrong units, should be meters, 6 meters. Okay, let's do one word problem. I'm going to just highlight as I go. It says a 13-foot ladder leans up against a building. The base of the ladder, that's important, the base, that means the bottom of the ladder, is 5 feet from the base of the building. So the bottom of the ladder is 5 feet from the bottom of the building. Determine how high up the ladder the building, or how high up the building the ladder reaches. So that's what we want to find out. Okay, so let's draw this picture. You can keep it really simple. Here's my building. I'm just going to draw something like this. Okay, it would be best to use a ruler, but it's hard to use a ruler on my screen. And then we have a ladder that's leaning against the building. You can give it a few details if you want to, but I wouldn't spend too much time. There's my ladder. Okay, so let's label the parts that we know. First thing that I highlighted here is that the ladder is 13 feet long. So let's label that. Okay. And then it says the base of the ladder, that's right here at the bottom, is 5 feet from the base of the building. So that's this blue highlighted length I'm highlighting here. Now have a look at this picture here and see if you see the right triangle. Okay, now the question is, how high up is the ladder reaching? So I want to find this length here. I'm going to call that X. That's what I want to find out. So the right angle in this question is right here, where the ground meets the building. So in this question, I have the hypotenuse and one of the legs, and I need to find the other leg, which I've labeled X. So we can do X squared, and we want to use subtraction here because I have the longest side already. All right, so I have the hypotenuse, which is 13. I've got one of the legs, which is 5. So 13 squared is 169. If you subtract off 25, which is 5 squared, you get 144. And then remember, we need to unsquare this X on both sides to find out what it equals to. So it's 12. So the ladder reaches 12 feet up the building. All right.